Hey there, everybody. Welcome back. We are looking at multiple integrals over non-rectangular regions. This is Calculus 3. Let's just jump right into it. Here, we're going to have a problem that is not it doesn't have a function. We're just starting with, we're dealing with y equals x. This is a Calc 1 problem that was difficult to do in Calc 1. And we're showing how to make it easier when we switch to 3D. We could have a difficult region to integrate in the XY plane that's hard to integrate in one dimension, where we're just doing one integral. If we switch to two integrals, it becomes easier, but we need an upper surface. And what we're going to do is we're going to pick, we've got some terrible thing right here. We're going to use z equals 1 as the surface. Z equals 1 as the surface. And so that we get some, whatever it is, it's a three-dimensional shape. Volume is area times height, but since the height is uniformly 1, doing the volume is just like getting the area. So let's take a look at an example. It might be a little bit easier to see. We're going to, instead of doing the following problem with a single integral like we could in Calc 1, we're going to use double integration to find the area enclosed by x equals negative y squared and 3y minus x equals 4. So I got a picture of it here. And I drew the picture up. I drew the curves and I found the boundary points. Did it over here as some legwork because it's not intuitive just looking at it, knowing what it is. So I figured out when y equals 1, x is negative 1, and y equals negative 4, x equals negative 16, just by substituting the x equals negative y squared into the 3y minus x equals 4 function. Go ahead and look through that. It looks like going along x first, or integrating with respect to x first is easier. If we do it along y, we've got two regions, region 1 and region 2, and I don't like that. So I wrote these. If we're doing x first, clearly from left to right, the lower boundary is 3y minus 4. The upper boundary is negative y squared. And we found our boundary conditions for y is negative 4 to 1, doing some legwork over here. And so our function f of xy was just z equals 1. So z equals 1. So we're integrating dx dy. And you don't need to put the 1 in there. I put the 1 in there to make it clear what I was doing. It's coming from up here. Okay. We're integrating along dx first. We get x in there. We could have easily separated this integral, but I did not. I did along, well, no, we couldn't separate the integral because x is a condition on y. So we plug in x, the values for x, 3y minus 4 is the lower boundary condition, negative y squared is the upper condition. We integrate that with respect to y. We get negative 1/3 y cubed minus 3/2 y squared plus 4y. We're going from y equals negative 4 to 1. And you plug it all in. I was doing it by hand until I got to this point, and actually I did this point by hand too. 6, and I know this 6 into 120 would be 20, and then 5/6 I know is 83.33%. So I actually did this all without a calculator. You should honestly practice doing as much math, even basic arithmetic like this, without a calculator, so that you stop making stupid fucking mistakes on tests. Okay? You start noticing when something looks wrong when you start practicing math. FYI, if you look in the solution manual for this, it sucks ass. This is all it has. It says A equals this. It doesn't explain where it got f of x y equals 1. It just jumps straight to the answer. It skips too many steps. The solution manual isn't everything. Okay. We got one more video in this section, then we'll be done with 14.2. Peace.